Hello everyone, this is a continuation of These Go to 15, of the solve of These Go to 15 by Viking Prime. I got really close yesterday, but I made some mistakes somewhere along the way, so I've got to restart, because I don't know where I made that mistake. Anyways, this is part 2. Hopefully we'll finish it today, or in this video, for you guys, and let's go. Okay, we are restarting, keeping the time. Okay, again. So Schrodinger, we have... So you either have 1 and 3 here. You can't have 2 and 2 because they are in the same box. If we try to have 1 and 3 here... Sorry, if we try to have 0 and 4 here, that would mean there are 4 even digits here. And 4 even digits add up to 15. So this would have to be adding up to 15 if that were the case. So if this is 0, 4, so why can't this be 0, 4? These are even. So we'd have even here. We have even here. This has to be Schrodinger, and it's odd. Okay. Why does this not work? So this is even here. Aha, and that's why. We have even here. It must add up to 12 or more for this digit, so both of them must be Schrodinger. That's why it cannot be 04. So this must be 1 and 3. So this is odd, blank, so blank, blank, odd, odd. You could either have 4, 8, or 12 there. But we know there's 3 odds, so therefore it must be 4 or 8 as a value. This has... So the question is, why can't this be 0, 4 or 2, 2? Well, okay, hold up. This is odd, odd. That means it's 0, 1, 2, or 3 adding up. And it cannot be 1 or 3 because of the 1, 3 pair here. So this is 0 or 2. Since this is 0 or 2, this is guaranteed to be odd here. But since this is odd, this also must be odd, which makes that a 0. So that's 0, which is why these cannot be Schrodinger. So we have 0 here. This must be a 1, 3 adding up as values. But this is 1, 3 as a pair. This is 1, 3 as a pair. If this were 3 in value, we know these can't be Schrodinger. This is not Schrodinger. This is even in value. This has to be size 1 and 2 to add up to 3, or 0 and 3, but this can't be 0 or 3, 1 or 3, because this has to be 1 or 3 in value, and this must be 1 or 3 in value. And if we try to have 1, 2 here, that would be 3 here, 0, and then this cannot be adding up to 3 or less. So that's the problem with that. That's why none of these are Schrodinger. So this is 0, 1, and 3, which forces this to be a 2. This has to be 1 or 0, 1. We don't know which. These are obviously not Schrodinger. Because... Well, actually, this could be, technically. This is 1, 2, 3, and this has to be non-Schrodinger, so it's even. Which means the remaining digits in row, or column 6 are 4 through 9. And again, so in each row and each column, we have 1 Schrodinger, and it's either 2 evens, which add up to another even, which gives you 4 evens and 5 odd digits in the row, column, or region. It could be even and odd, adding up to an odd digit, which also gives you 4 evens and 5 odds. Or it could be 2 odds, which add up to an even, which gives you 6 evens and 3 odds in a row, column, or region. So here we know this is 3 odds and 1 even. So therefore this is 3 evens and 3 odds here. We don't know how box 5, the Schrodinger, what combination the Schrodinger is. Also, the endpoints here, it's adding up to 4 at most. And it cannot have 1, it cannot have 2. So it must be 0, 3, 4, and 0, 3, 4. Which means that's as a sum. So this must be 0, 1, 4, adding up in 0, 1, 4, right? If this is so, can it be 4, 0, and 4, 0? And the answer there is no. So if these were both 4, 0, the problem with that is this would guarantee all of these are even, and all of these are even. Well, that's 7 evens in row 1, which is not allowed. You can have either 4 or 6 evens in a row. So therefore, one of them must be 3 with 1. And the other one has to be obviously be 0, 4 still. So you're guaranteed 3 evens. 3 and 1. One of them is odd, one of them's odd, so we need another odd here. So that gives 3 evens, 4, 5, a 5th even, which means there must be 6 evens in row 1. Which means in that Schrodinger, there must be 2 odds becoming an even sum. And O1 cannot be a Schrodinger of 2 odds going to become an even, because it's an odd digit. So this is guaranteed to be odd. It cannot be Schrodinger then. So it must be 1 there, which is why we know that's 1. Then we are given these bit codes. And again, we have 3 in one of these, and then we have 1 here, and then 1 here. We need another 1 somewhere, and it has to be here. So this is even. Since this is even, this has to be 8, 9, or Schrodinger. I think we tried... What was it? I don't remember. This one became the even one. So I think we tried this as even. So if we had this as even, so this was even, this was all even here, then this had to be odd, and this was odd. Here we have an even and odd, because if this is an even value, it must have an odd digit there, or odd value there. This is even odd as a pair. This is even odd as a pair. So in box 3, we have 5 evens, which means this must be 6 evens here, and then, again, 2 translating to... So this would be, again, 0, 4, adding up. And this would have to be 3 and 1. But technically, this could be... So this is 3 odds. We know in row 1, the Schrodinger is 2 odds adding up to an even. So this can't be Schrodinger. This can't be Schrodinger either. So what happens if this is 0, 4? If this is 0, 4, that guarantees this is even, which means it's at least 12. We cannot have even, because then this would have... So this is Schrodinger in this instance, if that's the case. If this is even, it's 12 at least in value. So that means it has to be the sum of 2 digits. So we have to have 1 even digit there. So we're guaranteed 1 even digit here. This is even, so that's 1, 2, 3. This has to be 8 or 9 here. So this is Schrodinger, which means this cannot be Schrodinger here. And it must be two odds adding up to an even, right? Because we have 6 evens in this box. So therefore, it's two odds adding up to an even. So this is not odd. This would be even. This would not be even. That would be odd. So it's two odds adding up to an even, which means it can't be 7, 9. It's 5, 9, or 3, 9, or 5, 7. We don't know. So this is even and odd. This must be either, again, 3, 9, 5, 7, or 5, 9. Okay. We have 1 odd here, 2 odd here, 3 odd here. This has to be Schrodinger, so this is 1 without a... this is non-Schrodinger here, which means none of these can be Schrodinger. So either this is Schrodinger or this is Schrodinger. Okay, so how did I disprove this is the question. We have 1, 2, 3 evens. We have 3 odds. This has to be... it's odd, blank, blank, blank. So this is 0 through 7. So we have 0 through 7 here, and no 1 and 3. So 0, 2, 4, 5, 6, 7 as possibilities. There's no Schrodinger. So... yeah, how did we disapprove this? I don't remember. This is even. We have even, even. So this cannot be Schrodinger, which means this is Schrodinger or this is Schrodinger. This would be 8 or 9. Yeah, I don't remember how I disproved this. Well, we have to try to figure it out. So this is Schrodinger in that instance. Oh, this is 8 or 9, which means this is even, odd, odd. Okay, this is probably how. Bingo. This is even, odd, odd. We have 4 guaranteed odd digits in row 2, which means the Schrodinger in that row must be either 2 evens adding up to an even to give you 4 evens and 5 odds, or an even and an odd adding up to an odd. But this specifically because in the box has to have 6 evens. So therefore, it has to be 2 odds adding up to an even, which means this is a contradiction. In row 2, we need a Schrodinger that gives us 4 evens and 5 odds. But in box 3, we need a Schrodinger that gives us 6 evens and 3 odds, and they are both the same, which is not allowed. So that's why this is disproven. So we know this cannot be 0 and 3. Sorry, this can't be 0, 4. This then has to be 3 and 1. But do we know if that's... so 3 cannot be Schrodinger because in row 1, again, we have 6 evens. So we have 2 odd digits adding up to an even sum. So this must be odd and this must be odd, which makes that's a 3. These are all even. Since this is all even, we know this is an odd even pair. This is an odd even pair for the same reason. This must be even, blank, blank, even. So this is at least 9. So we tried having this as Schrodinger, and I think that failed. So if this is Schrodinger, this adds up to, it's either 9, 11, 13, or 15, because this is even. So this must be odd, right? So because this is even, that's odd. Therefore, we have to have, the rest have to be all odds, right? Because we have an even and odd adding up to an odd digit, odd value here. So the remaining digits must be all odd. We know this is not the Schrodinger, so Schrodinger is here or here. And this must be even, odd, odd, even, which adds up to 9. You cannot have, these are not Schrodingers, so they must be 6 and 8. Therefore, this is 2 and 7 as a pair, adding up to 9. But what does that tell us? I don't really remember. We have 2 odds here, 1 odd here, 1 odd here, and 1 odd here. So this must be even in that sense. And okay, that's the contradiction. So then because we have 2 evens here, this is the third one, fourth one, fifth one, we have the remaining digits are all, sorry, we have 5 odds. We have to have 4 evens left, which is 1 here, 1 here, 1 here, and this must be even. But then we have even, and that adds up to at least 12, which must be a Schrodinger. So then that would have 2 Schrodingers in the same row, so that's not allowed. So we know this is not a Schrodinger. Therefore, and it has to be even, odd, 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 even at least. So this has to be a 9. So this is 9, it's odd, and these must both be odd. Well, that must mean this is a Schrodinger, because, how did I prove that this was, you can't have 9 and then a non-Schrodinger here. If this is non-Schrodinger, then this would be 8. So 8 would be even, odd, odd, odd. So this would not be odd. You'd have, this is even, this is not even. So we'd have odd, odd, odd. So if this was non-Schrodinger, we have 8, 9. Then we have 1, 2, 3 evens, which you can't ever have. You can only have 4 evens or 6 evens in a row. And this proves, this would basically say we have 3 evens in this row. So that's why that can't work. So this has to be Schrodinger. So this is Schrodinger, which means the rest of the box is not Schrodinger. This can't be Schrodinger. It's basically, we know it's either, it's blank, odd. So this is Schrodinger, which means this can't be Schrodinger, so it's 1, which gives us a 2 there, so we know that's even. So we have 5 even cells in box 1. This must be an even here. And these are 0 and 4. And this box 1 must have the Schrodinger be 2 odds adding up to an even sum. So this can't be the case, which means this is 0, 4, this is 0, 4. So it could be here or it could be here. We're not sure which. 9 eliminates 9 here. We have, in row 2, we have 1, 2, 3, 4, 5 odds, which means this must be even. Oh yeah, that's also another thing. So this must be even. So we have, this adds up to, in row 2, it must be either even, adding up to an even, or even odd, adding up to an odd. That was, maybe that was the bad assumption here. So this could, okay, yeah, that was probably a bad assumption for me. So this must be, so we have to have in box 2, since this is basically giving us 4 evens and 5 odds in this row, in the box, it must be 4 evens and 5 odds, right? So this has to be, we have 1, 2, 3, 4, which means the rest are all odd. Interesting. So this is not, and this is the Schrodinger. So this cannot be 4, 6, or 8. We have 3, 5, 7, 9 here, 3, 5, 7, 9. This cannot be Schrodinger because of the Schrodinger in this box must be two odds adding up to an even sum. So this is 1, 3, 5, 7. And 1 can't be here because of 1 in the row. Yeah, so maybe that was the bad assumption. That's interesting. 9 is obviously one of these three here. Oh, this could be the sum of... Yeah, 9 could also be there. Never mind. So this is always even, and then we have an odd. So that's either 12 or 13. So if it's 12, it would have to be 4 and 8 adding up. If it's 13, it cannot be 4 and 8 adding up. So again, this has to be an even and even adding up to an even, or an even and odd adding up to an odd. Because we have four, this is guaranteed to have four evens in row 2 and 5 odds. So it must match also for box 2. If we have 4 and 8 here, that would eliminate all possibilities for that cell, which is not possible. So this does have to add up to 13. So this is Schrodinger and is not even, which means this is not odd, that's even. So this cannot be 4 and 8 because of the 4-8 pair. It's basically 5, 8, or 6, 7. So this is still the same. Okay. This can't be 5 or 7. This can't be... This is now... One of these is 6 or 8. So we have to have 0 here. So this is 0, 4, 6, 8 here. And this is 0, 4, 6, 8. This has to be 4, 8 here. We have in row 3. And this was where it was a little hairy. In row 3, we are guaranteed 4 odds, which means it must be 4 evens and 5 odds. So this must have an odd and 2 evens here. Since this is an odd and 2 evens, that means in this box, it has to be either 2 evens adding up to an even sum in the Schrodinger, or an odd and an even adding up to an odd sum in the Schrodinger. So this, in row 1, remember, we have to have 2 odds adding up to an even cell. So this must be Schrodinger here, and one of these 3 is Schrodinger here. So this cannot be Schrodinger here. This must then be 6 or 8, because it cannot be 0 or 4. And the remaining digits in row 3 have to be 0. This can't be 9 anymore because of the Schrodinger being here, and this having to be a non-Schrodinger even sum. So we know 9 has to be one of these 2. So this has to be 0, and it has to have 4. So we're guaranteed 0 and 4 here. So this is 0, 4, 6, 8, and 1, and no 1, 3. It's 5 or 7 here. 5 or 7. We are guaranteed this one of these is 9, and the other has to be an even non-Schrodinger. Because the Schrodinger in row 1 has to be one of these 2, because it must match this essentially set of values. So this cannot be 1 or 3. This has to be 5, 7 pair, which that's either with 6 or 8 here. Because again, this can't be 1, 3, or 9, and this has to be the Schrodinger, because it must be 2 odds adding up to an even sum. That's for row 1 and box 1, but box 3 has to have 4 evens and 5 odds, which is the opposite, which does not have that then. So this 5-7 pair eliminates 5-7 here. This is 3. Eliminates 3-5-7 here. It's 1. And again, these cannot be Schrodinger. Remaining digits. We have a 2 in one of these. And it has to be 2 with 5 or 7. So if this is 5 or 7, or this is 2, the first digit must be odd. So this is odd, which makes this an even number. So this is not 9, which means 9 has to be here. This is guaranteed to have 0 or 4, so 0 or 4 cannot be here. It must be 6 or 8 here, right? Because there's no other place for 0 or 4 in row 3. So this can't be 6 or 8, because we know this is 0 or 4. That makes this 0 or 4. This is odd, odd, which eliminates 5 and 7 as possibilities. So this must be even and is a 2. So no 2 there. So this must be 2 there, which means this cannot be 2 here. We have, this is not Schrodinger. And we have blank, blank, odd, odd. So this is either 0 or 4 or 8. Well, we have a 0, 4, 8 triplet now in column 5. Because again, these are not Schrodinger, because this is Schrodinger. And we have a 0, 4, 8 triplet, which means this cannot be 8. So to add up to 13, it must be 6, 7, which eliminates 6 and 7 in the rest of the box. 7 eliminates, this can't be 6. This is 0, 4, 8. 6 and 7 eliminates 7 here, so this is 5. No 5 here. Therefore, we have 0, 4, and 7 here. And again, we don't know which of this 3 eliminates this from being 3. But it could be 1, 2. If this is 1, 2, that would make this 1. 1, 2 would force this to be 3, which would force this to be 1, and 1, 2 would force this to be 1. So this cannot be, these cannot be Schrodinger's either. So 3 eliminates 3 here. This is 1, which makes this 3, which makes that 1, which makes that 3. That means this cannot be 3. Where's 3 in row 3? It has to be there. We have, again, 0, 4, 4, 8 as a triplet in column 5. That leaves us 1, 2, 5, and 9. Oops. 1, 2, 5, and 9 remaining. I think we tried having this be 4. If this is 4... Right, we only have 1 even left in column 5. If this is 4, that means this is odd, even, odd, odd. But the problem is, then this would have to be 0, and this would have to be 8. And 8 has to be even, odd, odd, odd. So this cannot be 4, it must be 8. Which means this is even, this is odd. It cannot be 1 or 2 because of the Schrodinger in the column, so it's 5 or 9. Can't be 1 because of 1 in the box. It can't be 2 because it must be odd and not a Schrodinger. So this is 5, 9 as a pair, which eliminates 5, 9 in the rest of the column. 8 eliminates 8 here. This is 0 or 4, which both have odd as the first bit. So this is odd, which means this is even here, so this is 1, and that's 2. We don't know which one this is. 8 cannot be here. This must add up to 7. 1, 2, 3, 4, 5, 6, 7. And again, this can't be 0, 1, or 3. So this is at minimum 2. And it has to be 2 and 5. Because it can't be 4 and 4 here. So this has to be 2 and 5 and cannot be Schrodinger's. Because Schrodinger here would have to be, I don't know, 0 and 2, which we can't have a 0 in the row. This would be 0 and 5, or 1 and 4, or 2 and 3, but we can't have 0, 1, 2, 3 here. So this is 5, that's 2. So this is odd, this is even. This is odd. So that means we have blank, even, blank, odd. So that leaves this as blank, even, blank, odd. So that's 4 or 6. Or 12 or 14. We don't know. This is 7, so is odd. We have 5 odds in box 3. This cannot be odd. It's 7. So these have to be 2 even digits adding up to an even sum for the Schrodinger. Okay, this is, we have blank, blank, odd, odd, which is 0, 4, 8, 12. So this is even and is 0, 4, 8, 12. Or 12. This is odd, odd, blank, blank. And we have to have odd, odd, which is 0 through 3 here. We have 0 through 3. We need to have 3 odds here. So this has to be a 2. I think I came about this a very convoluted way of solving this. But this basically has to be a 2 because you have to have 1 even on this line. And so 0 doesn't work. 1 and 3 don't work because of 1 and 3 in the row. So this has to be 2. So this is 2, which makes this odd, odd, even, odd. This is even here. This is even here. We have, well, that doesn't help. Okay, this is then odd, even. And we don't know. Two is here, 2 is here. 1 can't be here, here, or here. So 1 has to be one of these two. 1 has to be one of these two. Column 7 has 4 odds and an even. Sorry, 4 odds, which means it's, 4 odds, which means it has to be 5 odds and 4 evens. Can't be 6 evens and 3 odds. So, and this, so it could be Schrodinger here. We don't know. This can't be 5. 5 eliminates 5 here, so this is 9, which makes this 5, which makes that 9. So no 5 or 9 here, no 5 or 9 here. We have 4 odds in column 6. So it's either 2 evens adding up to an even Schrodinger, or an even and odd adding up to an odd value Schrodinger. We don't know. Remaining digits of box 5. We have 2, 4, 5, 6, 7. And this can't be 2. This is odd, blank, blank, odd. We don't know. So this is even in value. We have even here. We have 4 evens already here. Hmm. This is an odd even pair. Right? Because either if this is odd, that makes this an even value. If this is even, that makes this an odd value. So we have in column 8, 1, 2, 3, 4, 5 guaranteed evens, which means this must be 6 evens. Which means in column 8, the Schrodinger must be 2 odd values summing up to an even value. 2 odd values. So therefore, this cannot be the Schrodinger. This has to be the Schrodinger in box 3. Because again, we have to have 2 evens in box 3 adding up to an even sum. So that's not going to work for column 8 because we have 6 guaranteed evens in that column. So this is Schrodinger, which means this cannot be 12. This cannot be 8. This is 0 or 4. 0 or 4 has an odd digit here, which gives us 5 odd digits. And we have all of them. This is 7 and 9. This is 7 and 9. This is Schrodinger. This must be an even left in column 7 because we have 5 odd digits. And this is 0, 4, 6, and 8. 9 here eliminates 9 here, so that's 7. This is 9. Where is 9 in box 6? It has to be here. So that's 9. So this could be this. Can it be the sum adding up to 12 or 14? 14 doesn't work because we have a 9 in the column, and the only way to add up to 2 even odd digits adding up to 14 is 5 and 9. So 14 doesn't work. 12 doesn't work because, again, it must be 2 odd digits. So it's 3 and 9 or 5 and 7 adding up to 12. So that doesn't work. Can you add up to 4 or 6? 6 would require 1 and 5. And that doesn't work because, oh, this is also blank. So this is now 4 or 6. We have even here and odd. So this has to be 6. And you can't have a Schrodinger there because 2 odd digits would be 1 and 5. And we already have a 1 in the box. So this must be non-Schrodinger and is 6, which means this is odd. We have even, odd. Odd, even, odd. That means this cannot be 6 here. We have 1 odd, 1 guaranteed odd. So this cannot be odd. This is even. It could be the sum of 2 digits. This is now odd, odd, which means this is a 0. So this cannot be 0 here. Where is 0 in box 3? It has to be here because it can't be here or here. Therefore, this can't be 0 here. It's 4, 6, or 8. This is an odd digit, and it's not a Schrodinger because, again, you have to have 2 odd digits adding up to an even sum in the Schrodinger in column 8. So this is not Schrodinger. It's not 1. It's not 9. It's not 7. It's 3 or 5 here. We have 1 in one of these 2 cells. So this must be odd, even. So it's 4 through 7 in value here. No 6, obviously, because of the 6 in the column. 7 eliminates 7 here. So, and 7 here, that means one of the 7s in box 5 is there. The 7 in box 6 is there, which means this cannot be 7 in total. And it can't add up. You don't have 0, 1, 2. I guess you could have 3 and 4 here. No, because Yeah, you can't have a Schrodinger. Okay, so 7's here, which means this cannot be 7. As a Schrodinger, this would have to be even and would have to be 1, 3, right? Because again, in column 8, we have to have the sum of two odd digits add up to an even sum. So if this were Schrodinger, it would have to be... It could not add up to 7. It could add up to 4 or 6. But 1, 5 eliminates both of those possibilities, right? 1 here means this can't be 1, 3, adding up to 4. It also means it can't be 1, 5, adding up to 6. So this must be non-Schrodinger, and it must be either 4 or 5. We're not sure which. If it's 4 or 5, that means it's odd, even, odd. So this is odd here. This can't be 6 because of 6 in the row. Remaining digits in row 6 are 4, 5, 7, 8, 9. No 9 here because of 9 in the column. This is 7. And if it's a Schrodinger, it's 7 and an even digit. If it's not Schrodinger, it's 7 and it's still an odd digit here. So 7 plus an odd digit plus an even digit is always an odd sum. And odd digit by itself is always odd. So this is guaranteed to be odd. We have 1, 2, 3, 4 odds already. That doesn't help us much. Remaining digits of box 8. We have 0, 4, 6, 8, no 7, and 9. This can't be 9 here. So 9 is one of these two. This, if it's a single digit, it's even. If it's at Schrodinger, it's even. So this is guaranteed to be even here. We are guaranteed that 9 has to be one of these, and 7 has to be one of these. So it cannot be two odds in that box adding up to a Schrodinger. Okay. 2 can't be here. Remaining digits of row... This has to be 3 or 5. Because it cannot be 1, 7, or 9. 1, 9 here, and 7 here. 7 can't be here. 1 has to be here, and 7 has to be one of these two. So 7 can't be here, 7 can't be here, 7 can't be here. Therefore, it's 1 and 7. One of them has to be at least in one of these cells. And it has to be Schrodinger in one of them. Well, this could be odd, but if this is odd, again, the Schrodinger is two odds adding up to an even. So if this is odd here, that would guarantee this is not a Schrodinger, which would mean this is Schrodinger here, because it would have to be a 1 or 7 adding up to yeah, actually, hold up. Yeah, it would have to be 1 and 7 as a Schrodinger here. Right? So if we had this as odd, even if that's odd, the problem is it can't be the Schrodinger because in column 8, the Schrodinger is two odd digits adding up to an even sum. So if this is odd, 1 or 7 is there, but only one of them, and the other one has to be there and therefore it must add up to an even sum, which would be a Schrodinger. If both of these are even, then 1 and 7 have to be essentially one of these two here to add up to an even sum. So this is Schrodinger also. So one of these two is Schrodinger. This cannot be Schrodinger. So it's not 0, 2, 6. It's 4 or 8. So we're guaranteed Schrodinger's here. Schrodinger has to be one of these two. We don't know which. And because there's a Schrodinger here, it's 2 odds adding up to an even sum, which means we have 6 evens in this box and 3 odds. Well, one of these is odd. This is odd, that's odd, which forces both of these to be even. And we have 5 evens guaranteed in this line. So this cannot be odd. It's even, which means this can't be even. It's odd. Therefore, this is 5. So we have odd, even, odd, even, which is adding up to OE, which is 5. So this is 3. 5 eliminates 5 here, so that's 3. So one of these two is Schrodinger. We don't know which. We have 5 odds in row 8, which means the rest of this row is even. And it has to be 0, 2, 4, 6, 8. 2 cannot be here because of 2 in the row. We don't know which of these is Schrodinger, though. This has to be even, though, because 4 and 6, if it's Schrodinger, adds up to an even sum. If it's not Schrodinger, it's obviously a single digit. We have 4 evens in box 5, so we don't have anything yet. One of these two is Schrodinger. Remaining digits in box 6 are 4, 5, 8, 9. And obviously 9 cannot be here. 8 can't be here. Remaining digits of column 8 are 1, 7, and 4, 8. And again, the 1 and the 7 have to be the Schrodinger together. Remaining digits of box column 9. We have 0. Okay. And what else? 0, 4. It has to be all even digits. So 0, 4, 6, and 8. Okay. So let's take a look at the bit clocks we have, just to make sure that they're kosher. We have even, odd, odd, even, which adds up to 9. We have even, even, odd, even, which adds up to 13, which 6, 7, 7 add up to. We have odd, odd, even, odd, which adds up to 2. We have even, odd, 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 which adds up to 8. We have odd, 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 which adds up to 0. 4 odds adding up to 0. Odd, even, odd, which adds up to 6. Odd, odd, even, odd, which adds up to 2. Odd, even, which adds up to 5. This is guaranteed to be odd, so it cannot be 8 here. So it's 0, 4, or 6. This is even in the second spot, so it's odd, blank, even. Well, 4 doesn't satisfy that. 0 doesn't satisfy that, so this must be 6. So this is 6, which means this is odd, even, odd. 4 has to be even as a singleton. That eliminates 4 from the rest of the row and box and column. This can't be 4, so this must be 6. No 6 here. This cannot be Schrodinger. This can't be Schrodinger because it's a single digit. So where is Schrodinger in column 6? It must be here. So this is Schrodinger. We know 4 can't be here. No 6 either. Whereas for this is odd, 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 odd. So that's 0, which makes this not 0. That's 4, which makes that 0, which makes that 4. So 4 eliminates 4 here. That's 8, which makes this not 4 or 8. It's 0. That means this can't be 0. This must be odd, and it's not. This has to have a 7 in it, but it must be an even value. So this must be Schrodinger. So this is 5 and 7, which means this can't be 5. This is 2 and is even. This is Schrodinger, so this cannot be Schrodinger here, so this must be 9. This is Schrodinger. This is Schrodinger then. This is odd. This must be 5 with an even digit, so this must be an odd sum there. So in column 9, we have 5 odd sums, because we have a sum of an odd and an even digit in the Schrodinger. In box 6, that works also. We have 5 odd digits, which is because the Schrodinger is a sum of an odd and an even. In row, this is 4, 5, and 8. Therefore, the remaining digits are 0, 1, and 3. 1 can't be here. This can't be 0 or 3. This must be 1, which eliminates 1 here. This is 0, 3 as a pair. This is 5, 7, so the remaining digits in the row are 2, 4, and 6, which are all even. So we have 6 evens in row 2. We have 6 evens in box 5. We should have 6 evens in column 4. Okay, so this cannot have a 6 here. This cannot have... cannot be 8. It's 4, 7 as a Schrodinger, which eliminates 4 in the rest of the row. This is 0, 2, and 8. 4, 2, and 4 eliminate 2 and 4 here, so that's 6, which eliminates 6 here. This can't be 6 there. None of these are Schrodinger. One of these 3 is. One of these 2 is a Schrodinger. This cannot be... This is odd, so this must be 9, which makes this 8. So there's no 8 here. So 8 in column 7 has to be here. So this is 8, which means this can't be 8 here. This is 6, which makes this not 6. So one of these is 8, which means this can't be 8. That's 6 here. This can't be 6. This is 4 and 8 as a Schrodinger, which eliminates 4 here, so that's 6. No 6 here, no 6 here. And then again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, it could be 0 here. That's where I made the mistake. It could be 0, and this is a Schrodinger adding up to 12. And in fact, it has to be that way, because we found out the hard way that it was basically running into issues otherwise. Right? This is 1, so this is odd. Row 4 works because... Okay, so this was the issue. This was the bad assumption. Okay, remaining digits of row 7 can be 1, 4, 5, 6, 7, 8. No 1, 6 here, no 1 here, no 6 or 4 here. Remaining digits of row 9 are 0, 1, 3, 4, 7, 9. No 0, 1, 3 here, no 1, 9 here. This cannot be 4. Okay. So why does 3 and 9 fail? So this is either 3 and 9, because these are singletons, or it could be 0 and 12, which I didn't take into account. But I think that's the actual answer. We know these are singletons, cannot be Schrodinger. One of these is a Schrodinger. Right. So, uh, one has to be one of these two. Okay. If this is 3 and 9, that means there's only one odd digit amongst all of these. Otherwise, they're all even. We don't know if this is Schrodinger or this is Schrodinger. 9 has to be one of these two cells. And I think, yeah, we just have to show that if you have 3 and 9 here, it fails. If you have, okay, yeah, so 9, okay, yeah, where's 9 and 3 in row 9? 9 can't be here because of 9 in the column, so 9 is either here or here. 3 can't be here because of 3 in the column, so 3 has to be one of these two. If this is 3 and 9, that eliminates 9 here and 3 here, which means 3 and 9 both have to be there, which would mean it's a Schrodinger. But if 3 is there, this is 0, which makes this 8, so this can't be 8, and that must be 5, 7, and is definitely a Schrodinger. So we'd have two Schrodinger in the same column, which is why this cannot be 3 and 9. So this has to then be 0 and 12. And the only way to add up to 12 is a Schrodinger of 5 and 7, which eliminates 5 and 7 in the rest of the row. This can't be 5 or 7, it's 8, which makes this 9. 0 makes this 3. Therefore, all of these are even. So we have to have all evens here. Because of that, these are 3 odds. 8 eliminates 8 there, so that's Schrodinger. Which means this can't be 5 or 7. This is 8, which makes this 0. No 0 or 8 here. This has to be odd. And we have 6 evens in box 7. So therefore, the remaining digits are odd values. This 8 eliminates 8 here, so that's 2, which makes this 8. There's no 8 here. 8 can't be here. 2 eliminates 2 here, so this is 4 and 2. Therefore, this cannot be 4 here, no 4 here. This, the Schrodinger here cannot be here or here. It must be the sum of 2 odd digits adding up to an even. So this is odd and odd, which means this must be the Schrodinger. So this is Schrodinger, which means this cannot be Schrodinger here. So this must be Schrodinger here. So this can't be 1 and 7. This must be 4 and 0, which makes that 8. No 4 and 8 here. This is 1, 7 as a pair. 4 eliminates 4 here, so this is 8. There's no 8 here. This is 4, 5 as a pair. 1, 7 eliminate 1 and 7 here, so it's 5. This can't be 5 or 7. It's 6. This can't be 5 or 7. It's 4. This can't be 4 or 7 because of 7 in the column, so this is 9. This can't be 0 or 7, so that's 3. And that's the solution. This can't be 3 or 9. It's 1, 7 as a Schrodinger. Okay. So I didn't have to go that far back. But I didn't realize that. Huh. So I had done everything correctly. I just didn't I didn't recognize this could have been 0 and 12. Interesting. Well, that was cool. Frustrating, but cool. I was very close, and I just didn't think that this could be 0 and 12. Ugh. Okay. Well, learn something every day, right? Anyways, I hope you enjoyed the Solve Over 2 videos, and hopefully you caught this before I did, and realized this could be 0 and 12 here. Otherwise, you'd probably have the same problems that I did. Anyways, I hope you enjoyed the solve either way, and I'll see you next time on Frank Puzzles. Take care.